Alright, so 7.2 is going to be on verifying identities. The reason we verify things is because sometimes graphing two expressions or entering values into a function is just misleading. So that's why we verify them. So in the beginning of our math careers, for example, we didn't know that 1 minus x times 1 plus x equaled 1 minus x squared. Okay, we didn't just know that off the top of our heads. So the way that we can verify this is that we can FOIL. Okay, so if we take 1 times 1, we get 1 plus 1 times x minus x times 1. Whoops, that should be a minus x times x. Okay, 1 times 1 is 1, plus 1 times x is x, minus x times 1 is x, and then minus x squared. Okay, this plus x and that minus x cancel out, and what we get is we get 1 minus x squared. See? So that's how we can verify something, is that we don't assume what we know, but we take steps on this side to simplify or to shuffle things around to get it to look like the thing we want it to. Okay, so what would we have done if instead the function that we were verifying was 1 minus cosine of theta times 1 plus cosine of theta equals sine squared theta? Okay, I don't know about you guys, but I didn't know that. So what we're going to do is we're going to kind of prove it to ourselves or verify. Okay, so just like we did with the x, we're going to do 1 times 1 plus 1 times cosine minus cosine times 1 minus cosine times cosine. You don't have to do all these steps. So that's 1 plus cosine theta minus cosine theta minus cosine squared theta. Okay, these cosines go away, and I get 1 minus cosine squared theta. Okay, but remember I have a Pythagorean identity that tells me that 1 minus cosine squared theta is the same as sine squared theta. Okay, so this equals this, and the story checks out. Notice that when I was verifying this, I didn't work both sides of the equation. Okay, so I didn't leave this on the end and then add cosine to the other side. I just worked one side and used the Pythagorean theorem to show that this was correct. Okay, so we can also take advantage of these new trig tools that we have in rewriting expressions. So for example, let's say that we're asked to rewrite tan of x plus cotangent of x as a product. So product means we're going to be multiplying two things together as a product of two trig functions. Okay, so the first thing I do in situations like this is that I rewrite things in terms of sine and cosine. So tangent is the same as sine x over cosine x. And then cotangent is the same as cosine x over sine x. Okay, now I'm going to draw a little sidebar here. Now we have to find a common denominator. We're going to do that the same way that we would if we had x over y plus y over x. Is that we're going to multiply this one by x over x. We're going to multiply this one by y over y. And what we're going to get is that we're going to get x squared plus y squared. X times x is x squared. Y times y is y squared. And that's going to be all over our new common denominator, which is going to be xy. Okay, so sometimes if you get to these steps and they look confusing or you don't know where to go, just go ahead and substitute in variables. So for example, you could have done a over b plus b over a, etc. Okay, so now if I were to do that over here, I would multiply this one by sine x over sine x, and this one by cosine x over cosine x. Okay, and then I get sine squared x plus cosine squared x all over sine x cosine x. Okay, so even though I can stop here in regular algebra, over here I have a really sweet identity that tells me that sine squared plus cosine squared gives me 1. So this is going to equal 1 over sine x cosine x. And I can also rewrite this as 1 over sine x times 1 over cosine x. And now I can use the reciprocal identities to rewrite those as cosecant x times secant x, which are two trig functions being multiplied together. So I rewrote them as a product. So that would be my answer. So it asked me to rewrite these as a product of two functions. So obviously out the gate, I didn't know that it was going to be these two multiplied together. I wasn't even really sure where I was going, but I knew that somehow I had to get these pushed together. So I had to find a common denominator. And then through that, I saw this neat 1 appear at the top through a trig identity. And then that led me down here. So don't worry if you look at a problem and you're not sure where to go. Sometimes you just kind of have to fall down your own rabbit hole. Sometimes you have to do it wrong once or twice. I always see it as a neat puzzle that I kind of have to, I don't know what it's going to look like until I start falling the pieces down to my answer. All right, so let's look at factoring. Okay, so let's say that we were asked to factor something like secant squared theta minus 1. Okay, so let's start out by factoring something like x squared minus 1. Okay, this is kind of like our previous example. We know that we can factor this out and do x plus 1 times x minus 1. Okay, and I can do the same thing here with this. So if I factored that out, that would just be secant theta plus 1 times secant theta minus 1. And that would be done. All right, so just some simple factoring there. Okay, now what if I was asked to factor out something like 4 sine squared theta minus 3 sine theta minus 1. All right, that looks a little intimidating. I don't know about you guys, looks a little scary to me. Okay, so again, what you can do is that you can just let sine equal x. Right, and you can rewrite it as 4x squared minus 3x minus 1. Okay, so I see I have a negative 3 here, and I have a 4, and I have a negative 1 here. So that gives me some inclination that I'm going to have something like 4x plus 1 times x minus 1. Okay, so I knew I'd have a plus and a minus here because my ending number is subtracting. All right. So now we can do the same thing over here and just let x equal sine. So we'd have 4 sine theta plus 1 times sine theta minus 1. And that would be a fine answer. Okay, so now, before we get into actually verifying identities, I would like to go over the do's and don'ts of verifying identities first. Okay, so the verifying do's and don'ts. All right, so only work one side at a time. Why is that? Okay, so we'll get to that in just a second. So what you're going to do is that you're going to cover up one side and work the other by simplifying or carrying out the operation. All right, so for example, if I was asked to verify that tan theta over cotangent equals tan squared, I wouldn't divide both sides by tangent, and I wouldn't multiply both sides by cotangent. What I would do is I would cover up this side, and I would start carrying out the operation on this side, which is division. Okay, so I would say tan theta over cotangent is the same thing as tan theta over 1 over tangent theta, which is by the reciprocal identity. Right, and then remember, dividing is the same as multiplying by reciprocal. You multiply by the reciprocal, and you get tan squared theta, which is what we wanted. So we are A-okay. All right, so then here's an example of what happens when you work both sides of the equations. So sometimes when you work both sides of the equation, you're going to verify something that might not be true. In this course, we'll only be verifying identities that are true, but if you go on to later courses, you might not know. You might be verifying data that you just collected and you're not really sure what's going to happen. Okay, so let's say that we want to verify that 1 equals 0. 1 definitely does not equal 0. Okay, so let's work both sides. So let's minus 1/2 from both sides. Okay, so we have 1/2 equals negative 1/2, which still isn't true. So let's go ahead and square both sides. So then if I square both sides, I get 1/4 equals 1/4. So even though I got something in the end that was true, because 1/4 definitely equals 1/4, that doesn't tell me anything, because I know 1/4 equals 1/4. I was trying to prove that 1 equals 0. So just because I get something true at the bottom, doesn't mean that what I started out with was true. Okay? And see, I have a little sad face right there, so don't do it. Okay, moving on to some more rules. Don't just enter values to prove equality. So for example, let's say that you wanted to verify that cosine of theta equals sine theta. Well, we know that that's not true. We can see multiple places on the unit circle where that's not true. But let's say that I just happen to randomly pick a really good angle that would work, and I choose 45 degrees. Okay? So I know that 45 degrees, cosine of 45 degrees is root 2 over 2. And I know that sine of 45 degrees just happens to also be root 2 over 2. So that's great. Again, this is true, but that doesn't tell me anything about this guy. See? Because we know that sine and cosine are not equal. Okay, so that's why we'd only work one side of the equation. All right. So, final do is try re-expressing the terms as functions of sine and cosine. All right, so this is like my earlier example, where I have 1 plus sine squared times secant squared equals cosecant. All right, so if I have 1 plus this, I'm going to change this into terms of cosine, since sine's already in terms of itself. Then when I multiply them together, I get 1 plus sine squared theta over cosine squared theta, which gives me a hint that I'm going to be turning that into a tan. And then 1 plus tan squared theta, I know that equals cosecant squared theta by the Pythagorean identity, So I know that that's true, because I only used the stuff that I had over here. So I didn't muckle with this stuff over here. Okay, and then again, whenever you see a 1, think the Pythagorean identity. Okay, and really quick, I'm going to show you what happens if I only work one side of the equation of something that's not true. So we know that cosine theta doesn't equal sine theta, but let's verify. So I know that cosine squared plus sine squared equals 1. So if I subtract sine squared theta from both sides, then I get that cosine squared theta equals 1 minus sine squared theta. Okay, And then from there, I get that cosine of theta equals square root 1 minus sine squared theta. Okay? So then what I'm saying is that the square root of 1 minus sine squared theta equals sine theta. Well, that's not true, because if it was, then I would square both sides and I would say that 1 minus sine squared was the same thing as sine squared, which it's not. There's no value that I could put in there to make that true. So then this argument would be false. Right, so that's like a neat thing that we get if we work both sides, or just one side of the equation, is that we can take something that somebody's claiming to be true and then prove that it's not. That's a very, very powerful tool. All right, so then the next example video, we'll be doing examples from 7.2.